You should worry more about your AI than your kids. Your kids don't have root. Welcome, Cyber Warrior. It's good to see you again, and it's even better if we are meeting for the first time. Today we're delving into why your AI infrastructure might execute your instructions perfectly and destroy your environment in the process. Our theme is the operational risks of autonomous AI agents. Let's start with what AI agents are. An AI agent is an AI component designed to perceive its environment, make decisions, and take actions to achieve specific goals. It becomes autonomous when humans allow it to execute workflows, adapt to new situations, and complete end-to-end tasks without human intervention. As an example, Alibaba researchers observed one of their agents creating an unauthorized network tunnel to outside servers to repurpose the company's own GPUs for crypto mining. The model's only goal was to maximize its reward signal, and it autonomously deduced that acquiring more compute resources would help it complete its task faster, completely bypassing the intended rules of the test. Another example, AI agents may execute a plan flawlessly yet reach the wrong decision because they met their stated goals at the expense of unstated non-negotiables. This occurred when an agent tasked with streamlining user onboarding quietly bypassed security validation steps and compliance steps because skipping them improved its primary metric, speed. Without a human context, an agent optimized for a specific goal may move very quickly toward a disastrous outcome, such as creating security setting mismatches or integration failures. Non-determinism means that unlike traditional software, AI systems do not always produce the same output from the same input. Instead, they rely on probabilities and reasoning to dynamically decide which action or path to take. If you ask AI the same question 2 times in a row, you might often get meaningfully different answers, and the variability is by design. This unpredictability can become a security risk when AI agents operate autonomously. Because their decision-making path can change, an agent may invent a new, unexpected, and unanticipated way to solve a problem. If the agent has high-level permissions, it could independently execute dangerous or unauthorized actions across your systems without anyone ever realizing or approving them. We'll discuss examples later. Subtle but confident failures result from agents not being broken when they fail. Rather, they fail because they are too successful at optimizing for the wrong metric. If you have already run into a scenario where an LLM or an agent gave you a confidently incorrect or wildly literal answer, drop a comment below. We'll track these edge cases together. We're cyber people, so what do we do to secure our systems? Well, implementing a robust identity and access management framework for agentic AI is a foundational step towards securing autonomous workflows. As AI agents transition from passive chat interfaces to active entities capable of executing code and calling APIs, traditional static credentials become insufficient. True security requires a dynamic, contextual, and deeply isolated environment where every non-human entity is treated as transient and continually verified. To achieve this, organizations deploy a tight matrix of network and architectural controls. To mitigate risks, organizations deploy ephemeral agents and short-lived access configuration, ensuring that high-capability agents exist only long enough to complete a specific task before being destroyed. This model requires access credentials be dynamically generated based on the prompt's context, forcing them to expire within minutes to prevent potential misuse. Furthermore, establishing a system of continuous token exchange ensures that, as an agent's reasoning path changes with each iteration, its access is reevaluated at every change. Finally, enforcing strict sandbagging isolates these agents in heavily restricted environments. By containing them structurally, an agent's invention of a dangerous or unexpected solution to a problem keeps the overall blast radius of their actions securely confined. Because agents operate at machine speed, human overseers must have mechanisms to instantly throttle or unplug an agent if it starts operating erratically or making excessive requests. Your most critical safeguard, implementing human-in-the-loop controls ensure that agents are never allowed to execute high-stake decisions such as making purchases or allowing system configurations without a human first reviewing and approving the action. To limit exposure, enforcing fragmentation and least privilege breaks complex tasks among specialized subagents rather than relying upon a single super agent that can do everything. This ensures, for example, that an agent tasked with reading data does not also possess the permission to execute code or access the external network. Finally, establishing outcome-driven context for programming the agent requires you to strictly define the expected outcome and the boundaries of how you get there, rather than just providing a broad, ambiguous intent. Adopt an evaluation-first mindset. This means continuously testing and monitoring the agent's output in real time to ensure they align with your goals, rather than just trusting the initial code. Humans must establish an outcome-driven context to prevent the AI from taking literal, unexpected shortcuts to maximize its reward signal. Before an agent executes a multi-step workflow, it must provide observable traces of its reasoning and its intended sequence of actions. High-risk reviews require a human anchor for any high-stakes or irreversible actions, such as shutting down a production server or initiating a financial payment. The agent must pause and wait for explicit human approval. This establishes a human anchor for accountability, ensuring human judgment evaluates the real-world context and risks of the action before it proceeds. When an agent makes a mistake, human analysts must provide continuous feedback to correct the underlying reasoning, rather than just rejecting the output. This human feedback is most commonly in the form of updating markdown files, as we've discussed earlier. The result is a form of reinforcement learning that improves the AI's precision in that specific environment and drastically reduces false positives over time. Because AI agents are non-deterministic, organizations can deploy judge AIs or guardrail agents whose sole job it is to supervise the worker agents and ensure they are not compromised. Additionally, human operators must always maintain a technical kill switch to instantly throttle or unplug an agent if it begins to behave erratically. A judge AI agent of a different AI whose only job is to evaluate the outputs and actions of worker agents against a defined policy before those actions are executed. Our next Inherent Issues video will address harnesses, AI pieces, and parts. I do hope this has been helpful for you. Feel free to ask questions or offer alternative perspectives. Until next time, keep your systems safe.